In part A, we determine the intervals of increase. We have been given this function f of x equals 12x power 2 by 3 minus 4x. So to determine the increasing or the decreasing intervals, we should find the critical point of the function. And this is determined by solving the equation f prime of x equals 0. That is, the derivative of the function f of x equals 0. So let's find the derivative of the function f of x, that is f prime of x, and this equals, we find the derivative of the right side expression. So let's find the derivative of 12x power 2 by 3. I put this constant 12, and then to find the derivative of x power 2 by 3, we use the power rule of derivative. That is, we put the power in front and raise x to the power of 2 by 3 minus 1. So this equals 2 by 3 minus 3 by 3. This equals 2 minus 3 by 3, which equals negative 1 by 3. So I write negative 1 by 3 minus the derivative of 4x is 4 times the derivative of x is 1. So let's simplify this. We have f prime of x. This equals, we can reduce this to simple fraction. This goes 4 times, and 4 times 2 is 8. So we have 8x power negative 1 by 3 minus 4, or this can be written in positive powers of x as 8 divided by x power 1 by 3 minus 4. We can also write this as a single fraction, that is 8 by x power 1 by 3 minus, we multiply this 4 with x power 1 by 3 and divide by x power 1 by 3, so that we get a common denominator. Now we have the common denominator x power 1 by 3. So therefore this becomes 8 minus 4x power 1 by 3 divided by x power 1 by 3. This is f prime of x, that is the derivative of x. Now we have to set this up equal to 0. So replace f prime of x equal to 0 and solve for x. So we get 0 equals 8 minus 4x power 1 by 3 divided by x power 1 by 3. And so this is 0 when the numerator is 0. It is 8 minus 4x power 1 by 3 equals 0. Solving this, we get 4x power 1 by 3 equals 8, or otherwise x power 1 by 3 equals, dividing by 4 on both sides, we get 2. So we cube on both sides, that is x power 1 by 3, we cube it, and here also we cube it, it is 2 cube. So these two will get cancelled, leaving us x. This equals 2 cube, which is 8. So this is one of the critical point of the function f of x. We also state that the critical point is obtained when the first derivative is undefined, that is f prime of x is undefined. So using this condition, we can use this equation of f prime of x, and this is undefined when the denominator equals 0. That is when x power 1 by 3 equals 0, or otherwise when x equal to 0. So basically we get two critical points, that is x equal to 0 and x equal to 8. Now, using this critical point and the first derivative of the function f of x, we prepare a sign chart for the first derivative of the function and determine the increasing or the decreasing intervals. So I'm going to prepare a sign chart for f prime of x. So I put this number line and mark the two critical points, that is x equal to 0. Let's say this is x equal to 0 and this is x equal to 8. So these two are the critical points. This is basically sign chart for the first derivative. Now we should take some random values to the left and to the right of each of those critical points. So first let's consider this critical point x equal to 0. Let's take a sample point like x equal to negative 8, which is to the left of x equal to 0, and plug it into the first derivative. We just need to understand the sign. We don't need the exact value. So therefore, when we plug it here, this will become 8 minus 4 times of negative 8. This x power 1 by 3 is basically cube root of x. So negative 8 cube root divided by negative 8 cube root. And so this gives cube root of negative 8 is negative 2. And negative 4 times negative 2 is positive 8. So it will be 8 plus 8 is 16 divided by a negative number. This is cube root of negative 8 is negative. So this is giving negative. So let's mark negative to the left of x equal to 0. Now we can consider any sample point to the right of x equal to 0, or it becomes to the left of x equal to 8. Let's say we consider x equal to 8 and determine the sign of the first derivative. Let's plug it into the first derivative. So we will have 8 minus 4 times of cube root of 7 divided by cube root of 7. And so this gives 8 minus cube root of 7 is going to be less than 2. So 4 times of a number less than 2 will be less than 8. And so this will be less than 8. Let's say this is somewhat like 7.7. And this one under divided by cube root of 7, let's say it is 1.9 or something, which is less than 8. So this is going to be positive because 8 minus a number lower less than 8 is going to be positive, and the denominator is also positive. So we have a positive number. So we can mark positive to the right of x equal to 0 or to the left of x equal to 8. Now let's take some random values to the right of x equal to 8. We will take a perfect Q number so that it will be easy for us to calculate the sign. So we are going to plug this into the first derivative f prime of x. So here we have 8 minus 4 times of cube root of 27 divided by cube root of 27. And so this gives this cube root of 27 is 3, and this will become 8 minus 4 times of 3 divided by cube root of 27 is 3. And so this gives this one is 8 and this one is 12. It's going to be negative in the numerator and the denominator is positive. Sorry about it. So the denominator is positive. So a negative number divided by positive number is negative. So we can see that to the right of x equal to 8, it is negative. And this means we can now say that whenever the first derivative is negative, it is decreasing. So we can see that it is decreasing. Remember that at x equal to 0, it is undefined. That means we have a vertical tangent. So we can mark it like this. And at x equal to 8, it is 0. So we have a horizontal tangent. And afterwards, it is decreasing. So it is like this. Okay, here I have redrawn the graph of f of x after preparing the sign chart of f prime of x. So we can see that whenever the first derivative is negative, the function is decreasing. So we see that it is decreasing in the interval negative infinity to 0, it is decreasing. Also, we see that greater than 8, it is decreasing. So in this interval also, it is decreasing, which means we put union 8 to infinity. The function is decreasing. And the only increasing interval is from 0 to 8. So this interval, the function is increasing. So we see that increasing interval is from 0 to 8. This is 8. Also, using this, we can determine the relative maximum and relative minimum. That is, we can answer the part B to determine the x and y coordinate of relative maximum points. We can see from this first derivative sign chart the function reaches the maximum at x equal to 8. That is the x coordinate. To find the y coordinate, we plug it into the function f of x. So let's replace the function f of x, which is 12x power 2 by 3 minus 4x. Plugging x equal to 8, we get f of 8, and this equals 12 times 8 power 2 by 3 minus 4 times 8. This is 8. And so this gives 12 times of, I can write 8 power 2 by 3 as 8 power 1 by 3 raised to the power of 2 minus 4 times 8 is 32. And this is 8 power 3, 1 by 3 is cube root of 8, which is 2. And 2 square is 4. 12 times 4 is 48. So it is 48 minus 32 equals 16. So therefore, we can see that the xy coordinate of relative maximum is 8, comma the y is 16. So this is the xy coordinate of relative maximum. Now let's put the relative minimum. That is, we are answering part C. You can see from this first derivative sign chart, whenever it is whenever it changes from decreasing to increasing function, we see that it's a point of minimum. So this is the point of minimum. Here it is maximum. That is 0. When x equal to 0, it is minimum. We will find the corresponding y value by plugging into the function. So we get f of 0 equals 12 times of 0 power 2 by 3 minus 4 times of 0. And so this is 0 minus 0 is 0. So we say that the xy coordinate of relative minimum is 0 comma 0. This is the xy coordinate of relative minimum. Let's answer part D. Here we determine the concave downward interval. For this, we should find the second derivative and set this up equal to 0 or it is undefined. So let's consider the first derivative function, that is f prime of x, and this equals 8 minus 4x power 1 by 3 divided by x power 1 by 3. And so we can write this as 8 by x power 1 by 3 minus 4, or otherwise we can write this as 8x power negative 1 by 3 minus 4. Now let's find the second derivative by differentiating this first derivative function. This is first derivative. We find second derivative, and so this equals, we find the derivative of this expression, that is 8 times of, we put the power in front and then raise x to the power of negative 1 by 3 negative 1, and this equals negative 4 thirds. So this is negative 4 thirds. Derivative of negative 4 is 0, so we just ignore that. Let's simplify this. This is f double prime of x, and this equals negative 8 thirds x power negative 4 thirds, or otherwise we can write this as negative 8 by 3x power positive 4 thirds. We say that the second derivative is undefined at x equal to 0. Okay, so f double prime of x is undefined at x equals 0, because when the denominator equals 0, it is undefined. So we will prepare the sign chart for the second derivative so that we can determine the concavity intervals at x equal to 0. We take some random values to the left and to the right of x. Let's take some negative 8. We will take x equal to negative 8 and plug it into the second derivative. And when we do that, this quantity is always going to be positive, because we have negative 8 divided by 3 times of, let's say we put negative 8 raised to the power of 4 thirds, we can write as 1 third raised to the power of 4, because since we are raising it to the power of an even power, this quantity, irrespective of whether it is positive or negative, is going to be positive. So this one, the second derivative, is always going to be negative. That is, we can say that it is a negative here. Also, to the right of x equal to 0, whether we put a positive number in the denominator, it's still going to be positive, and the numerator is negative. So overall, it's going to be negative. And so therefore, we can say that it is concave down in these two intervals, that is from negative infinity to 0, and then union 0 to infinity. So in these two intervals, the function is concave downward. We now sketch the graph of f of x using the information that we have determined from parts A through parts D. So here I have drawn the sketch of f of x, showing all the information which we determined from parts A to parts D. That is, I have shown this. This is increasing interval from 0 to 8, and in the interval negative infinity to 0 and 8 to infinity, it is decreasing. I have also shown that relative maximum. The relative maximum is at 8, 16, and the relative minimum is at 0, 0, and the concave downward intervals, that is negative infinity to 0, as well as from 0 to infinity, it is concave downwards. So this is basically the sketch of the function f of x.